So if you remember back, before we got the quadratic formula, which was just Friday, we were solving these by factoring. So the equation had to be factorable. Okay. The answers always look kind of the same. But they always had to work out, kind of nicely. Integers or rational answers. By that I mean like fractions. But now with the quadratic formula, things really explode in possibility. Any quadratic equation that has a solution, we can find it. And in fact, quadratic formula tells us more than just what the solution is. If there isn't a solution, it'll tell us that. It can help tell us what our solution is like. That'll make more sense as we go through these examples. It's really powerful in lots of ways. It's very useful. All right, so let's get started. We're going to show exact answers. We'll talk a little bit more about what that means as well as rounded to two decimal places. So on Friday, I believe we did an example that had decimals, and I said you could just take those decimals and put them right in the formula, right? No reason why you can't. But today we're going to do it a little bit differently. So we're going to see what it looks like when we get rid of the decimals. Remember this skill from Unit 1 in this year. So in fact, what we're going to do is multiply everything by 10, because in this case, that will get rid of the decimals. Don't forget to multiply constants. Like everything, right, has to be multiplied by 10. Even the right side 0, even though that's only going to give us 0. Got to remember to do it. Yes? I don't know why I did that. Thank you for asking. I have no idea. It doesn't make a difference, but you're right. I wouldn't normally. Okay, so the rest of this works out to 10 times 1.2 is 12x squared. 10 times 1.4 is minus 14x. 10 times 1 is minus 10 equals 0. So that might, to some of you, that might look a little bit nicer. I don't know. Instead of the decimals. You might like this better. What else do you notice about this? I could put this into the quadratic formula. No problem. But I notice there's a common factor in there, right? So I can actually divide both sides by 2. And what does that give me? 6x squared minus 7x minus 5 equals 0. And those are smaller numbers. Maybe I can do a little bit more of the math in my head when I plug it into the formula. All right, so now we're ready. Let's go ahead and do that. Negative 7c equals negative 5. So x equals negative b plus or minus. By the way, just watch for a minute. Some people like to do this. They cheat on their square root sign. That's kind of really wrong because it makes it look like it's just b squared that you take the square root, which doesn't make any sense because that's just the opposite. So it really does. If you're lazy, if you're in the habit of being lazy and not doing that, it's kind of really wrong. Like, I know you probably think that, oh, what's the big deal? But it kind of is a big deal. Same thing with divided by 2a. If you're in the habit of doing that, I would really try to say, break that habit, because that looks to me really ambiguous. What is being divided by 2a? Just the b squared? Just the radical part? Which part? So you should get in the habit. Some people scoff at those little things, but that can actually help you do better in math class and understand it better, and watching those little details sometimes is just like makes your life easier. Okay, so negative b, which is negative 7, which is positive 7. Negative 7 squared minus 4 times 6 times negative 5. Now I want to talk about something before we go and do this, so just watch for a minute. Oops. All over 2a, so 2 times 6. If you were doing the practice and you kept getting a negative under the square root sign, do you know what I'm talking about? Which means that can happen, and it means there's no solution, and that is perfectly fine. Sometimes that happens. If it was a quadratic like this, it would have no solution, right? It would have no answer. However, this one does have an answer. So if you were doing the practice and you got a whole bunch of them work out that way, you're probably doing it wrong. If they're all working out that way, it's probably something you're doing. Here's the 2 common mistakes that would give you a negative in the square root sign. When I square negative 7, the negative is in the square root sign, so that part will always be positive. If you put negative 7 squared in your calculator and get negative 49, you've done it wrong. So the great thing there is you don't even have to worry about that. Like if you just know it's supposed to be positive, then you just write positive 49. I don't even put the negative in my calculator. I just do 7 squared. It's 49. Whether it's negative or positive won't matter because it's in brackets. For quadratic formula, right? It's always in brackets. The second part is I've got 2 negatives, so whatever works out there is going to be plus. I just know that. I do the signs part in my head. Then if I need my calculator to multiply the numbers, I'll do that. But do the signs in your head. Because it works out to 120. 4 times 5 is 20 times 6 is 120. So if I had 49 minus 120, I'd get a negative, but that'd be wrong. So those are the 2 common mistakes. Messing up the sign for the b squared part or messing up the sign for the 4ac part. Yes? Right. 2 times 3 times 4 is the same as 3 times 4 times 2 is the same as 4 times 2 times 3. Order of multiplication does not matter. Okay. 49 plus 120 is square root of 169 over 12. Put your pencil down and watch for a minute. This is where some people go like this. Oh, so it's like the square root of 20. So that's like the square root of 4 times 5, which is 2 root 5. They want to do that to square root of 169. But what is the square root of 169? 13. Don't try to simplify it the hard way. If you can take the square root of something, it's funny, like when I say exact answers, that doesn't mean you have to have a square root sign in it. It just means you can't, if the square root is a decimal, don't do that. That's when you leave the square root. But if it gives me the square root of a nice number, do it. Of course. Well, why did I put 12? Of course, it's just 13. Okay? Is that good? That means x equals, so that's your exact answer, kind of fully, well, not really fully reduced, but that's as far as we can go till we split it up into 2 parts. So 7 plus 13 is 20 over 12. Divide the top and bottom by 4, and I get 5 over 3. And this is negative 6 over 12, which is negative a half. Yes? Can we write the answer in decimals? No, absolutely not. Exact answer means fractions. The negative 1/2, if you wrote that as 0.5, that wouldn't be the end of the world, but 5 over 3, you'd round it. That's absolutely not correct enough. We need to know how to keep our answers perfect. That's just a skill that we need. Okay, I want you to watch something. Notice what happened. We got the square root of 169, which is 13. We got fraction answers. So I'm going to tell you when that happens, 100% of the time, the thing that we had in the beginning was factorable. This is how you know, if you use quadratic formula, when you're halfway through, you'd be like, darn it, I could have factored. Darn. So if I go back up, what was this? 6x squared minus 7x minus 5. So 6x squared minus 7x minus 5 equals 0. So I've got 5 and 1. So that's going to be 2x and 3x, and this one is minus and plus. So therefore, 3x minus 5 is 0. 2x plus 1 is 0. So x is negative a half, right? Same answers. 5 over 3. So that was like 2 steps, and quadratic formula was a lot. I did a little bit of extra work in the quadratic formula, but it was a lot more work. That's why you factor. That's why we like to be good at factoring. One of the reasons why we like to be good at factoring. But that's interesting to know that if it's factorable, you're going to get a perfect square, radicand, so a perfect square under the square root sign there. And if you get a perfect square under the square root sign, it was factorable. Like there's 100% one-to-one correlation there. No. There will be a section of the test that says solve by factoring. There will be a section of this, it'll be like 1 or 2 questions. There'll be a section of the test that says solve using the quadratic formula. Again, 1 or 2 questions. And then there will be a bigger section that just says solve. It won't be that big. It won't be like the factoring test, where it'll have like maybe 4 questions that you can do either one. So if it says solve by factoring and use quadratic formula, then you're going to lose marks. But otherwise, and for all the word problems, so you can use either method. But the quadratic formula is slower. Okay, and you're maybe more likely to make a little mistake here or there with the negative sign and get the slightly wrong answer. I don't know. Any other questions? So it's just interesting to notice that that square root tells us a lot about what the question was like. Okay, let's try another one. What do I do for this one? What's going to be my first step here? Mahmoud?
Move everything from the right equal sign to the left.
Yeah, and?
Expand.
And expand and simplify everything. That's right. So go ahead and try that. Give you a minute, see if you can get the right answer. You could do whatever direction you want to move things. Does it affect the stuff in the bracket? Well, first of all, I want you to try it, and you can do it however you think is the right way, and then you get to compare it to my answer and see if it's right. I would expand first and then move things around. That's the way I would do it. How are we doing? Did you get 3x squared minus 7x minus 22? Yeah? Nice. So again, we did this a while ago, but I expand these 2 brackets first, get that trinomial, then multiply the 3 inside. I expanded those, then I moved them over, changed signs, then I collected like terms. All right, this one is not factorable, so just go ahead, try the quadratic formula. Good chance to reflect, look for all those little things. Whoops. like the brackets around the thing that you're squaring. What should I have under my radical sign? Anybody have that? Liam, what'd you get? 313. Anybody else get 313? Awesome. Yeah, good. 313. Does that reduce? I don't think so. What, like, you know how you're supposed to reduce a radical if you can? So you have to find a perfect square factor that goes into 313. Okay, so 4 or any even number is not. That cancels out a lot of the possible options. What else maybe would then? 25 won't. Again, we know multiples of 25 easily. So 9 you could try. 49 you could try. 81 you could try. 121 I guess, but like then I mean nothing, right? So nothing, so it's not reducible. But people think, oh, 313, I don't know what goes into 313. There's not that many numbers you'd have to try. Probably on a test you wouldn't get something like that you'd have to reduce, but even if you did, it's really not that bad. If 13 is a prime number, does that mean that nothing will go into 313? It doesn't seem like it would. I agree with that. We don't have a rule that anything that ends in a 7 is prime, but anything that ends in a 7 isn't necessarily also prime, right? 27, right? So does that work for other kinds of, I mean, it's not a rule that we have. But I agree with you. It doesn't look like much is going to go into it. Okay. So that means we've got x. So that means that part's done. We can't reduce it any further. So x is 7 plus square root of 313 over 6. And x equals 7 minus square root of 313 over 6. Try those on your calculator. See if you can get the right answer. It's good practice. Don't forget brackets around the top part. And don't just copy down my answer. Make sure that you can get it. Okay, any questions? Is that okay? Yep, Liam. Quite sure. 7 minus something big is going to be negative.
Oh, yeah, sorry.
Okay. All right, C. How do I do C? This is great practice for our quiz on Wednesday. What do we do? Jaden. How do I do that? I would love to be able to get rid of fractions because I hate I don't really hate fractions, but I know you guys hate fractions. I hate fractions. I love to do that, but I don't know how. Jaden, can you tell me how?
Multiply by the lowest common multiple of the equation.
Awesome. So, which in this case is 6. So if I take 6 and I multiply everything by 6, it's going to get rid of the fractions. What does that look like? 6 times x squared plus 1 over 3 minus 6 times x minus 2 over 2. Don't forget the rest of it. Some people stop there. They're like, oh, I'll just multiply it by the ones that have fractions. I don't have to worry about the others. Yeah, you do. You got to multiply everything by 6. That's what keeps it balanced. Megan? Yes. Okay, so go ahead and finish this. So in grade 9 or even earlier in this year, I might have made you write this out, or not made you, but I might have suggested to write it out. But now we probably know that I can just distribute these numbers through, right? That's what it would look like. So it's going to be 2x squared plus 2 minus 3x. And this is a little bit tricky. Oops, that's going to disappear. Shoot. This is a little bit tricky for some people, I think. This is like -3 times -2. So that should be plus 6. So watch that. Two plus 6 is 8, minus 30 is minus 22. Equals 0. Again, it turns out this is not factorable. No common factor. That's always good to look for. It would be, if it was factorable, it'd be fairly easy because 2 is prime. So check, but in this case, it's not factorable. Nine plus 4 times 2 times 22. What's that? Anybody have that? 185. Same thing. It doesn't immediately jump out at me that that's reducible, but I kind of feel like, what would you divide that by? You could try dividing by 5 and see, but 5 isn't a perfect square factor, so you know, whatever you get would have to work. 25 is not going to work. I don't know what's going to work. Try 49, I guess. Try 9, but it is not reducible. So we get x equals 3 plus root 185 over 4. And x equals 3 minus root 185 over 4. Everybody okay? Yeah.
I'm not getting the same answer as you am.
Try, like after we do this, try with a bunch more. Make sure you're getting the right answer, okay? And then ask me again. Okay, couple more examples. Let's keep going, keep going. All right, let's do this one. Obviously, this one's factorable, right? Two numbers that add to 2 and multiply to 2, 1 and 1. Right? Am I right? Doesn't that work? What? Does that not work? Two numbers that add to 2 and multiply to 2, 1 and 1? I think that.
I don't even know when we're supposed to do like the complex trinomial or like.
We'll talk about that after. But we'll talk about that at the end. Right now we're using quadratic formula. So we're not doing any factoring. Some people, I don't know, for some reason this one looks like it might be factorable, but it's not. 1 times 1 is 1, not 2. But anyway, we're solving with these with the quadratic formula, so no tricks here. Let's just go ahead and solve it. And what do you get under the square root sign? Who's done? Secure it? -4. All right, so keep going. What happens when you get a -4? And you try to take the square root. Secure, what do you think? Pardon me? Yeah, you can't take the square root of a negative number. That won't work. It'll give you an error. What does that mean? No solution. It actually means no real roots, which seems a little strange, but there is a solution in other kinds of mathematics, but in grade 10 there's no solution. So you just say no solution. You don't have to say no real roots. But see how good the quadratic formula is? It even tells me when there's no answer. If I was factoring, I'd have to try factoring, not get it, and hope that I didn't just miss it. And I wouldn't know if there was an answer and I can't find it by factoring or if there's no solution. But with quadratic formula, there's no doubt there is no solution to this quadratic. There is no value of x that can make that true. Try. Try a few values yourself if you don't believe it, and you'll see pretty quickly that it's not possible. Okay? So no solution. That's what it looks like. You get a negative under the square root sign. We already saw if you get a perfect square under the square root sign, what that tells us, it tells us it's factorable. Okay? Okay, one more. Same thing, we're just going to go ahead quickly and get this one done. I want you to kind of catch up to where I am, and then you can just stop and wait for a minute. Watch. What is negative 10 all squared? 100. So I've got a negative. I've only got one negative, right? And it's 4 times 1 times 25. So it's going to be minus. And 4 times 25 is 100. What's 100 minus 100? 0. What's the square root of 0? 0. Therefore, this is kind of a waste, but just for the sake of the lesson, 10 plus 0 over 2, or x is 10 minus 0 over 2, which obviously going to give me the same answer, right? So 2 different ways with the plus and the minus. I got the same answer, okay? That's because I had the square root of 0. Again, what did we learn before? It means that what I had was factorable. And if you didn't notice, x squared minus 10x plus 25 is x minus 5, x minus 5. It was a perfect square trinomial. That's why we got the 0, which means, whoops, therefore x is 5 and x is 5, right? So I could have factored that one, but we were just trying it, see what happens when you put when you do the quadratic formula on one of those types and you get 0, you get the same answer twice. If you think about the graph of that, you would also understand why. Like if you completed the square and graphed it, there's a lot of connections to be had there. Okay? So that is what happens in that case. We looked at all the different kinds of cases. If you get a negative, if you get a perfect square, if you get 0, if you get any other number, then the square root sign for a quadratic equation tells you what's going on and what the answer is like.